Hi, everybody. So this is Cakewalk SONAR. My name is Noel Borthwick, and I'm a CTO at Cakewalk.
And
Nice to see you all.
Oh, sorry. And I'm Pete Brown. I work in the Windows and Devices group here at Microsoft. Awesome. We're all done. So there we go. All right.
That's a demo.
So in this talk, we're going to show you some cool things that we're doing in Windows 10 here. We've got Cakewalk, which is a pro audio partner who is going to show how they were able to light up on Windows 10 from their Win32 desktop application. And also, if you're a musician or if you're into pro audio, I think you're going to find a lot of cool stuff here. So actually, how many musicians in the room? All right.
All right.
Excellent. How many music app developers? Cool. All right. You're going to have to keep your secret sauce to yourself. I think we've got a couple of spies in the room. All right. In Windows 10, we have added a number of new features specifically for pro audio applications. So many of you may not realize this, but we added support for Bluetooth MIDI in most awesome, thank you. One person who has Bluetooth devices, sweet. We also added support for low latency audio with Wasapi, which is a really big deal for musicians. That's for onboard audio on the devices themselves, like what Noel was running here on the Surface. We added support for Thunderbolt audio, which is, again, some nice inbox work that we did to make it possible for driver authors to be able to create audio applications or audio devices that use Thunderbolt. And then finally, we just released in the Creators Update an inbox USB audio Class 2 driver, which, again, is a really big deal for us and very important for being able to make it super easy for music app developers. There are also a couple of other features that I know Noel is interested in that aren't specific to DAWs and aren't specific to pro audio, but are still very interesting. So Pen is really great for doing things like drawing automation and doing navigation and very fine control when you're using DAWs and music applications. Touch, of course, super important when you want to do panning, or if you're doing like finger drumming or something like that, that it requires a really good surface with fast response for touch. And then finally, Dial, which seems like a really obvious thing, right? It's a big knob that you can have with your applications. It can control audio. It can control different volume levels or automation or anything that you would like. It's just another great input device. So before I turn this over to Noel, let me talk a little bit about Cakewalk here. We're on the stage here together for a reason. Cakewalk has a long history of working with Microsoft and working specifically with Windows to light up on the different versions of Windows and also to try out new features that we put in for pro audio. I think he's one of the best partners that we have for being able to try out some of these brand new features. They're some of the first Wasapi implementations, et cetera.
We're the guinea pigs.
Yes. Okay.
So like Pete says, we have a long history with Microsoft and working with Microsoft technologies. We actually started like 30 years ago, and Cakewalk, many people know of as a DOS app. It used to be a DOS app, and we were one of the first sequencers on Windows, and we embraced 64-bit audio, 64-bit processing, multiprocessor support. We were the first DAW to support like end-to-end 64-bit audio processing. And Wasapi, as we talked about earlier, was one of the new technologies is the Windows audio streaming engine. It came out around the time of Windows Vista, and we embraced it very early on. And it's now paying a lot of dividends because Microsoft has added like low latency audio support to it, and we're going to come to that a little later. We also embraced multi-touch support. So it's very natural for musicians to want to work with control surfaces. And with multi-touch support, you can use like a computer display or a multi-touch screen to actually do the same thing that you can do on a control surface. And that's it. So, and now we have Bluetooth MIDI. We're going to talk about that too. So the other great thing is, do you have a slide for the? You don't have a slide for the 30th anniversary thing, right?
That comes a little bit later.
So we're celebrating our 30th anniversary, which I think is one of the biggest milestones for us. So it's pretty interesting. We have a whole year of promotions. Go to our website. There's a URL there, and you can check it out. So that's the app which you just saw playing. It's a pretty rich app. There's a lot of features which range, if you're a professional, like our audio composer or our audio engineer, we have all the tools in here to help you do great productions. We're also great for like beginner musicians. This complex interface can be scaled down to like just show you all you need, like just to record like a simple audio track. And we have tons and tons of plugins in the box as well. and virtual instruments. We're going to show you some of that as we go along.
And you guys are doing a lot of advanced processing behind the scenes for load balancing and multi-threading. I mean, if you've ever wanted to learn best practices for dealing with multi-threaded applications, these types of applications are the ones to look at because they have to do near real-time processing of audio.
Right, and where multiprocessing comes in is like if you have, you want to play audio at low latency, you want to finish processing in the shortest possible time. So you want to use all your CPU resources available to you.
Okay.
So we've noticed through our analytics that we do is that the majority of our customers are on Windows 10, which is in a very short time, like DAW customers are normally the last customers to shift OSs because they find something that works and they stick with it, But it's very interesting that just in over a period of 2 years, we've seen that most of our customers have converted to Windows 10. There's still a few on Windows 7, but virtually nobody is on Windows 8, and a bunch are on the other OSs before that.
Okay. Now, the reason why that's really important is because there are a number of different ways that an application can light up on Windows 10. As you saw, Knoll still has roughly a quarter of the customers or so on Windows 7. So whatever they do still needs to support Windows 7. So you could write a UWP app. We've talked about that tons. That is a Windows 10 only solution. It's typically a complete rewrite and not necessarily appropriate for a DAW. You can use the desktop bridge. I hope folks here have taken a look at that. There's some really good technology in the desktop bridge there. There are some limitations around what you can install with your application. And if you're familiar with DAWs, they do things like install plugins as part of themselves, et cetera, which may not be visible to other applications, so that has some complexity. And then finally, the approach that Cakewalk used for a number of things here is, one, we have APIs in Windows 10 that have been updated for Windows 10 which aren't UWP, things like some of the Wasapi stuff with the iAudio Client 2, I think is right, or
3.
3, thank you. See, I should know this stuff. As well as being able to use UWP APIs, which you can use some of them as long as they don't require an application identity directly from a Win32 application. So let's talk about Wasapi.
Yeah. So Wasapi, Wasapi is actually not that new. It came out in around the time frame of Windows 8. And there were essentially two ways of talking to a Wasapi application. It's like you can talk to a Wasapi application using shared mode or exclusive mode. When it first came out, shared mode was, it ran at very high latency. It was kind of like the old MME model. So we didn't really adopt it at that time. But due to the advances in Windows 10, Wasapi shared mode can now run at very low latency, just like Wasapi exclusive mode. And it buys you all the great advantages that you can actually run SONAR along with another application, and Windows will mix the audio for you. So it's pretty handy. Like some people want to watch a YouTube video and they want to play SONAR at the same time. So it's been really useful. The other great thing about Wasapi is it allows us as a DAW vendor to target consumer audio devices. I'm running a Surface Pro here, and this whole demo is running through a Surface Pro using a Realtek. That's a Realtek audio onboard card. And we can go down to almost 3 milliseconds of latency on a consumer audio sound card, which is completely unheard of before. So it's pretty cool.
Okay.
Then the other neat features are you can do, it has a higher fidelity, so there's no SRC, automatic SRC conversion, sample rate conversion. And the performance is pretty consistent, and it's very flexible in the sense you can have audio endpoints, which are, you can have a microphone endpoint, and you can have a speaker endpoint, and you can stream audio between a microphone and a speaker just using Wasapi, it's very difficult to do even in pro audio models like Azio. So it's pretty cool. The other next area of interest is touch, pen, and hybrid devices. So we embraced multi-touch support very earlier on in probably about 2008 or 2009. And initially, the only multi-touch devices were these big screens you could get, which had multiple touch points, and they were pretty expensive. With the advent of machines like the Surface Pro, it's now everybody has a multi-touch device if you have a Surface Pro. So we've been investing more and more into that. Multi-touch is great for doing, big gestures like scrolling the app and zooming and panning. but it's not so great for doing very detailed gestures where you want to like draw automation or you want to draw MIDI notes and things like that. So we've started investing in pen, and we're shortly even going to be looking at things like dial very soon.
Cool. So another thing that we've done is the UWP MIDI library needed a bit of a wrapper around it to make it super easy for Win32 applications to use. It wasn't necessary, but I think for showing external customers how to wrap this and how to make these UWP calls from C++, it really helped them out. And that was created by Dale Stammen on my team. It exposes a flat API that wraps the UWP stuff and makes it super easy for these guys to call. So you can do detection in SONAR to check to see what version of Windows I'm running on, and if you're running on Windows 10, they dynamically load a DLL, and they're able to do some cool stuff with that. Okay?
Yep.
And then this is available. It's all open source. It's out on GitHub. So I think it might be good at this point. Can we go into a demo here?
Yeah, we should go into the demo.
Yeah.
So we're going to show you how we used UWP MIDI to support Bluetooth. One of the great advantages of the UWP MIDI API is it allows you to access devices like Bluetooth devices. And here's a Bluetooth MIDI controller. I'm going to just turn it on, and we're going to try and pair it up with Windows.
So if you haven't seen this, this is a MIDI controller using the Bluetooth standard. Okay? And we're actually going to pair this live on stage. That's crazy, isn't it? Okay. Go through. I see the nano key. Let's pair all their phones while we're at it.
It's connected.
Yep.
Stop blinking.
Yep, it stopped blinking. Sweet.
Okay.
Okay.
I'm going to run SONAR. And you're going to see we have a new mode called UWP as opposed to MME, which is the old MIDI driver mode.
Yep.
And I'm going to pick the nano key keyboard right here. And I'm now going to open a project.
And what you're going to see while he's loading this up is I'm going to play notes on here while there's a backing track going through. There are a few important pieces to that. One is you're using Wasapi for the audio engine in shared mode, so you're going to see it's fairly low latency, and we're using the Bluetooth API here for MIDI input. And that's the extent of my playing. Thank you very much. No. So go ahead and, do we have the track play? Yeah? They actually created a track because I said, oh, I can play keyboards, and I didn't realize they were going to make me actually do it. But the big thing here is look at this latency, right? So for over Bluetooth, which is important because I can do it from over here, right? And we have, let's see. Oh, I need to go and turn aside. Here we go, here. Let's see. So, that was the extent of my playing. Thank you very much.
So
the latency on that is spectacular. I think.
What do you think about it?
I actually really like it. One of the things I tried back in my house, I had one of these, and it's not the best set of pads, but I was able to do some basic finger drumming on it. But I think what people are here for, we've got a few minutes left, would be to see the code.
Yep.
And like, we promised that you would run a commercial product from Visual Studio here.
Sure thing. Whoever's an audio developer has put on a blindfold.
Yes. Everybody signed an NDA for this, right? It's all, yeah, okay, that's what I thought.
All right, so I'm going to launch up Visual Studio. Open up my project.
There you go.
And so I'm going to trace, initially I'm just going to show you how we set up the UWP APIs. So UWP is not, this is a Win32 application, so you have to do some extra stuff to actually use it. And as he said earlier, Dave Stammen wrote this DLL, which allows us to access the UWP APIs in a very simple way. So I'm just going to show you how we implemented it.
Okay. How many of you run your production shipping applications from Visual Studio in a demo? No, nobody, okay.
Okay, so the first thing, I've hit my first breakpoint here. Can you guys see all right? Maybe I should, all right. So the first thing we do when we start up is you have to be very careful when you're using this UWP MIDI API because it's only supported on Windows 10 anniversary update and higher. So you can see right here, we do a check. We say, can you do UWP MIDI? And if so, we load this library, which is the Win32 MIDI library. And the first thing, as part of our preamble, we collect all the exports from this library, which are just pointers to all these various functions. And you can see I have a class here which implements. So we have WinRT, a namespace which has all these function definitions. And these are dynamically loaded so that if we're running on Win7 or something else, it's still going to work.
Right.
So here's our initialization. I'm going to take you to the next part, which is where we really initialize UWP.
So I think C++ developers in a room, you're probably pretty used to this at this point. Where you dynamically load a library based on the operating system you're on, so you can have the same code base running on Windows 7 and Windows 10.
Yeah. So now we're in the UWP code, which is in the DLL, and you can see this is how the DLL initializes. Here it's calling into Windows Foundation APIs. It's calling Windows Foundation initialize. We initialize the Windows Foundation as single-threaded because our application is an MFC application, and if we do it as multi-threaded, it's not compatible with UWP. So that's one consideration if you're building a UWP app, you might want to take care of that. And okay, I'm going to move on to the next. So this is where the DLL gets initialized. And you can see it's creating various objects, which are like callbacks back to our code. And that's all set up now. And in a few minutes, you'll see what happens. OK, so right now, when the app is initializing, we are opening MIDI ports. Now, one thing of interest is like how we've implemented UWP, which is not, you don't have to do it that way if you're an audio developer. We have to support MME as well as UWP. So we chose to write our own layer, abstraction layer between MME and UWP, which is very convenient because the rest of our application thinks it's talking to an MME interface, but the call is going to get translated into UWP, and you'll see how that happens. So you can see we say get MIDI core, which is going to give me either MME or UWP, and I'm going to call MIDI in open, and you'll see how it gets translated. So here's MIDI in open in our UWP abstraction layer, and you can see in here it's calling into the DLL to say, please open this MIDI port for me. It opens the MIDI port, it sets up a callback in this wrapper and returns to us. We store that pointer, and we basically map this object to something so that we can find our private interface to this object in here. And you'll see how we use that in a minute.
Everybody thinks I just picked up a club down here to beat you with or something. So it kind of looks like it.
All right, so we're in now.
Okay.
And I'm going to open this project. We should open the same project, right?
Yeah, daily, I think.
Yeah.
So while Noel's doing that, there are lots of Bluetooth MIDI devices out there. So you were talking about this one before. It's the Pub, which translates classic MIDI to Bluetooth.
It's a pretty handy device.
This thing here looks totally cool, right? And yes, you could take a photo of me with this totally cool device right here.
This is a Jamstick. So it's like a MIDI controller, a Bluetooth MIDI controller.
It totally looks like an 80s headless guitar, right?
Yeah,
so I think it's kind of cool.
It's pretty neat.
And there are more and more of these devices coming out every day. Yamaha has their own interface to map to stuff, etc. Are we loaded on here?
We are loaded. And so what we're going to do now is we're going to trace what happens when he actually plays a note.
Right. So if I go
hopefully
over here,
it's going to hit my breakpoint.
There we go.
Boom, there you are. So this is, right now, it's in the UWP layer. If you look at the stack, you'll see it's in the Win32 MIDI DLL. And I got a message. And get the timestamp of the message. And you see how simple the API is. The API, unlike MME, which has all these crazy layers and you got to create handles to things and allocate memory up front, there's none of that stuff in UWP. It's very, very simple. It's like to use. So we're kind of going backwards. So we're taking the UWP call and now packaging it here. So here's where we get the buffer. We got a pointer to the buffer, get the data, and now we say, here's the message received callback. So I'm going to trace that callback. and boom. So here it is now. In my handler, I caught the message, got the port data, and you're going to see, oh, you remember earlier on I saved this in a map, right? I just dereference the map, get my context, and from there, now it says, what kind of message is it? Is it, we kind of figure out, is it a sysx message, or is it a short message, or is it a long message, or whatever, you know? So here we find out, he did a note on, so it's going to be a 3-byte message. We just set that, fill in all the bytes, and now it makes a callback, which is going to end up in the MME layer of our sequencer. So at this point, this code has no idea that it's UWP. It thinks it's just a MIDI in message. So it comes in here, we get the message, and get the data, add it to a queue, and that's it. So once it's added to a queue, our app is very asynchronous. So there's a queue, there's a separate multimedia thread, which is going to now render this queued item, and you're going to hear it. That's it.
Great.
I mean, that's basically the walkthrough of how UWP MIDI works.
And just to thoroughly embarrass him, I see Dale sitting over here on the side. So if you're wondering who created that wrapper API, is over there. Wave your hand. There you go. Cool. Thank you, Dale, for enabling that. So in summary here, and thank you for the demo. I think it's always cool to run production code on stage.
Not only production code, this is previously unreleased code, so I'm running like an alpha here.
Yeah, funny, even better, I guess. So in summary here, what I wanted you to get out of this is, one, we care about music and pro audio in Windows. We've been doing a lot to support that. Two, we like Knoll and we like Cakewalk because they're really great partners. Three, if you want to light up on Windows 10, you don't have to kind of eat the whole cake at once. There are nice ways that you can have your application do some specific things to provide value to your Windows 10 users. And then finally, I think, try Cakewalk Sonar for free. There's an aka.ms at the bottom there, which you can go ahead and try that out. The shipping version has Bluetooth MIDI support built in. This is one of the controllers that I recommend. It's not very expensive. It's like $130 or something like that. Purchase it from anywhere. So thanks again, Noel, for coming here and presenting this.
Appreciate it.
Thank you.
Thanks for coming by.
Oh, and I should mention that Noel is going to be over at the, what do we call that thing? The Solutions. The thing over there next to Derek's DJ booth. We're going to be like over there tomorrow afternoon. So if you have any questions, feel free to ping
there. You want to come and take a look at this stuff, that's fine.